Hello and welcome to the first of 6 chemistry lecture videos brought to you by the York Technical College Science Department. My name is Kyle Rourke and I will be presenting these lectures. The first part is naming ionic compounds. If we recall that an ionic compound is composed of a metal and a nonmetal, I have a few examples here. So table salt is sodium chloride, so NaCl. Then over on the right we have calcium carbonate, commonly referred to as chalk. And then below we have copper 2 sulfate. So as we can see here that we obviously have different naming schemes based off the metal and the nonmetal that we have. For example, we can have a group 1 metal and a group 7 nonmetal. We could have a group 2 metal and a polyatomic ion. So sodium will have plus, chloride will have minus, calcium 2 plus, and then carbonate 2 minus. And then we have transition metals that have different charges based off what they are reacting with. So copper 2 and then sulfate, so 2 minus for sulfate, and then copper 2 plus for copper. So again, recall that ionic compounds are metals and nonmetals. These are very stable because of the electrostatic interactions between the cations, which is our positively charged species, and the anions, which are negatively charged species. And since opposites attract, this is very strong compared to covalent bonds that have a sharing of electrons. These compounds have a transfer of charges or transfer of electrons. For example, we can show that sodium is in group 1 as 1 valence electron, and chlorine is in group 7 as 7 valence electrons. And what's going to happen is that this 1 valence electron for sodium is going to transfer to chlorine. So sodium lost an electron, going to become positively charged, and chlorine gained an electron, it becomes negatively charged. And then this electrostatic interaction holds this salt together. So as we can see, the names and the formulas can be deduced from the constituent elements on the periodic table, right? Sodium and then chlorine becomes chloride. And we're going to get into this in the next few slides. But first, I want to explain how the periodic table can help you. At first, looking at the periodic table, you can see a lot of different symbols and numbers, and it can be confusing on how to use it. But in fact, the periodic table is designed to help chemists and chemistry students and just make their job easier by the way that it is arranged. So for example, group 1 here tends to form 1 plus cations, right? Positively charged species. Okay. Group 2 tends to form 2 plus, right? We're going to skip the transition metals for now. Group 3A or 13, the only one that we need to worry about is aluminum, which forms 3 plus. And now we're going to talk about the nonmetals right here. And we have carbon, which forms 4 minus. Group 5A forms 3 minus charges. Group 6A, 2 minus charges. And group 7A will form a minus 1 charge. So why does this happen? This happens because the atoms want to achieve a noble gas configuration. So it wants to have the same electronic structure as a noble gas, which are the most stable and the inert. So they are not reactive at that point. So what happens for sodium, just like our previous example, right? It's over here in group 1 as 1 valence electron. So it wants to give up that electron and become the same electron configuration as neon. In contrast, chlorine, right here in group 7, wants to gain that one electron and have the same electron configuration as argon, which makes the atoms more stable. Okay. So how do we name these, right? So we're going to start with naming binary compounds, right? Binary just means two. And ionic compounds. So there are two types. Metals that form only one type of cation. These are group 1 and 2, aluminum, zinc, and silver. So to name these, name of the cation, which is the metal, and then you add the name of the anion, the base name of the anion, which is the nonmetal, and add IDE when you remove the last 3 or 4 letters of the nonmetal name. So for example, we can have KCl here, which is potassium, which is the metal, and then chlorine, which is the nonmetal, except we remove the last 3 letters I and E and replace it with IDE. So the name of KCl becomes potassium chloride. In contrast, you can have metals that form more than one type of cation. These are going to be your transition metals, just like before that we showed. This box right here, right? These are the transition metals. And they tend to form more than one cation. So you have to name the charge or indicate the charge that the metal has. And then the name of the nonmetal is the same base, but you remove the last 3 or 4 letters and add IDE. So for example, CrBr3 is chromium and bromine, and you remove the I and E and replace with IDE, so it becomes chromium bromide. But since it's a transition metal, you need to indicate that the charge on chromium is a 3+ charge. And you can get this by 2 different methods. I'm going to do the reverse crisscross method for our examples. But if you have 3 bromines and you know that the charge for bromine is a minus charge, then you have a 3- charge essentially on the bromine. And thus, to balance that out, the chromium has to have a 3+ charge. So let me just write this down. Right? 3+, and then Br going to be a minus, but you have 3 of those, right? But you have 3 of those. Okay. Hopefully that makes sense. And since the charge is balanced, then the compound is stable. I just want to talk about polyatomic ions briefly, right? Polyatomic, poly means multiple, atomic is the atoms, and then ions are the charged species. Polyatomic ions are composed of cations and anions with multiple atoms. That's all it's saying here. So most of them, except ammonium, would be listed after the metal or as the nonmetal because they are anions, right? These are all nonmetals except for, we have chromium here, we have manganese here, and so on. But the rest of these are nonmetals. So specifically, most of these are oxyanions because they have oxygen and they are negatively charged species. So to name these, right, we have for example, NaNO2. We have sodium, which is the metal. Don't forget, that never changes, right? Sodium and potassium and calcium, beryllium, whatever. Don't change the name of the metal. The only thing that's changing is the name of the nonmetal. However, for polyatomic species, don't change the name. Just add whatever name that the polyatomic ion has. So for example, NaNO3 is sodium nitrite because NO2- is nitrite. So it's really important to have these in your what I recall as the chemist toolbox. the chemist toolbox. Yeah, so what you need to become a great chemistry student and hopefully a chemist is these polyatomic ions. So sodium nitrite, excuse me. So, and then we have FeSO4. This is a transition metal here. So sulfate has a 2- charge. So by saying that, the iron has to be 2+ for the species to be balanced, right? Charge neutral. And then lastly, we have ammonium, and then nitrate. It's just ammonium nitrate because you have ammonium and then you have nitrate, 2 polyatomic species. Don't change either name. Just keep them the same. So the chemist toolbox is very important. Okay. So we're going to do a few examples to show, and I will do them next.